Hello, and welcome to the Good Manufacturing Practice training module presented by Cloud9 Consulting Limited. In this training module, you will learn about the key terms and requirements of data integrity. Our goal today is to understand data integrity as it is applied to computer systems and hybrid systems. A hybrid system utilizes aspects of both a computerized and manual processing system to record and control data. Consequences of not following data integrity requirements can lead to fatalities or injury to patients, loss of batches, product recalls, loss of reputation, regulatory inspection failures. Personnel responsibilities include but not limited to: all employees are obliged to report suspicious actions or data to their supervisor or management. A hybrid system is where we use both paper and a computer or automated system. For example, where data is generated as an electronic record using a computer system and is then approved using a wet signature on paper. What is data integrity? Data integrity is the maintenance and assurance of the accuracy and consistency of data over its entire life cycle. Not all data has the same importance to product quality. Risk management should be utilized to determine the importance of data. Data criticality, impact on decision-making and product quality. Data risk, opportunity for data alteration and deletion, and likelihood of detection and visibility of changes by routine review processes. From this information, risk-proportionate control measures can be implemented. Data or information used for quality-related decision-making must comply with the data integrity principles. The following sections will explore the principles of ALCOA and ALCOA+. Let's examine what these mean in terms of electronic and hybrid data. Data. Raw data. Audit trail. Archival. Try and match the definitions up. Data. Information that is generated or recorded at the time of the GXP activity and allows full and complete reconstruction and evaluation of the GXP activity. Raw data. The first capture of information, whether recorded on paper or electronically. Audit trail. A process that captures additions, deletion or alternations to a record, and retains the original entry, whether on paper or electronic. Archival. A process of protecting records from further alteration and deletion and the storage of these records in a controlled environment. Attributable. It must be possible to identify the individual who performed the recorded task. To demonstrate that the function was performed by trained and qualified personnel. This applies to changes made to records as well, corrections, deletions, etc. Signature logs are important and should be kept up to date. Records should be completed using good documentation practices. This is controlled by unique login and passwords. Shared or generic logins are not acceptable for any user of a GMP system. Data entered is associated with this person or login. Login does not equal electronic signature. Where a user is required to confirm or sign for information, the system should request that they do so by re-entering all or part of their login sequence. E-signatures must be executed at the time of the activity. If a wet signature is applied to a paper printout, and the intent is to confirm that the data is correct, it must not be possible to edit the data afterwards. GMP systems should have an audit trail that cannot be switched off. Audit trails should be reviewed based on risk management principles. Failure to review could result in erroneous or incomplete data being inadvertently accepted by the QP or person responsible for batch release. Access controls shall control the privileges of the users. An administrator should be assigned that should not be directly connected to the operations of the area where the computerized system resides and is used. This function is ideally performed by the Information Technology or IT department. Legible, traceable and permanent. Data must be readable and understandable and allow a clear picture of the sequencing of steps or events in the record so that all GXP activities conducted can be fully reconstructed by persons reviewing these records at any point during the record's retention period set by the applicable GXP. No temporary data storage. Data must be saved to enduring uneditable media at the time. It should not be possible to overwrite or delete data. All data should be visible to the reviewer or approver and should not be hidden. The data should be archived and uneditable after review. Contemporaneous. Confirmation that data is recorded at the time of generation. Secure control of timers, cannot be changed. Time zone controls. No save as, which could change the creation time of a file. Times recorded on paper should be consistent with times recorded electronically. Original. The original record can be described as the first capture of information, whether recorded on paper, static, or electronically, usually dynamic, depending on the complexity of the system. Information that is originally captured in a dynamic state should remain available in that state. Original data should be reviewed. Original data includes metadata. The dynamic relationship should be preserved. Metadata. These are data that describe the structure, data elements, interrelationships and other characteristics of data. Includes units of measure, time and date stamp of the activity, the operator ID of the person who performed the activity, the instrument ID used. Processing parameters, sequence files, audit trails and other data required to understand data and reconstruct activities. Accurate. Accurate means data is correct, truthful, valid and reliable. Manual entry of data verified by a second means for accuracy. Calibration of instruments. Validation of systems and data transfers and storage. Service agreements with IT, for example, backups, storage and restore. Specific details, for example, ownership and control where cloud-based systems are used. Agreements with service providers, for example, data control and ownership. Spreadsheets. Spreadsheets used to calculate and report data that has an impact on product quality or regulatory compliance must be validated. Controlled templates in place. Formulas or other types of algorithms should be verified for correctness. Checked for accuracy and reliability. Stored in a manner which ensures appropriate version control comply with data integrity requirements. Both files and the calculations should be secured in such a way that formulations are not accidentally overwritten. Accidental input of inappropriate data types should be prevented or result in an error message. The principles of ALCOA have since been expanded and are known as ALCOA+. These are: complete. All recorded data requires an audit trail to show nothing has been deleted or lost. Consistent. This primarily means ensuring data is chronological, for example, has a date and timestamp that is in the expected sequence. Enduring. While this is touched on in a previous principle, this principle of ALCOA+ places specific emphasis on ensuring data is available long after it is recorded, decades in some situations. Available. This point follows on from the last point, For example, data must not only exist, it must be accessible. The most efficient way of achieving this is normally by recording data electronically. The requirements for data integrity are detailed in the following publications.